Hello math friends! Today we are going to talk about a couple of growth models. The first one is going to be linear growth. The second one is going to be exponential. Now the difference between linear growth and exponential, we'll get into that in a little bit. But linear is going to, if we graph it, make a line. So it grows at a constant rate where we're adding or subtracting something every time. So linear is always adding or subtracting. Let's take a look here. Let's see here. We're going to give you two different types of formulas. The first one is called a recursive. And that is where something is reoccurring over and over again. Reoccurring. And what we do is we say, what's happening? What's reoccurring each time? And it might be adding or subtracting, that would make our linear, or it might be multiplying or dividing. This is going to make our exponential one where we multiply or divide. Now, what is the shortcut when we add something over and over and over again? When we add it over and over and over again, say if I wanted to do 5 plus 5 plus 5 plus 5, my shortcut for that is I want 4 times 5. When I want to multiply something over and over again, I'm going to say, if I do 5 times 5 times 5 times 5, that's going to be 5 to the 4th power. You see, this becomes an exponent when we multiply or divide something. This one, we're going to multiply by it. So we use multiplication in both, but in this one, we're really adding multiple times to make it multiplication. Here we're multiplying to make it exponential. Okay, drop the lid to my pen. So let's take a look here. So when we do a reoccurring, we're going to take a look at what's happening over and over again. If you take a peek on your assignment or in the book on page 175, the very first thing we talk about is someone who's got an antique bottle collection. And in his antique bottle collection, he's going to start with, these markers don't like to erase good. He starts with 437 bottles. And each year he adds to it. So if he adds to it each year, we know we're going to end up with a linear function as opposed to exponential because we're adding the same thing each time. So we're going to add 32 new bottles. So what happens in the recursive is we're going to each year add 32. Each year add 32. So he starts at 437. I'm going to rewrite this just a little bit. I'm going to rewrite it as a table. So at year 0, he has 437 bottles. Okay? At year 1, he's going to take that 437 and add, what did we say, 32 bottles to it, right? Yes, 32. Okay. In year 2, he's going to take that 437 plus 32, 437 plus 32, and add another 32 bottles. Okay, year 3, he's going to take that 437 plus 32 plus 32 and add another 32. Okay, so you can see what happens. What's reoccurring each time is we're adding 32. Each time we have added 32 to what was previously there, added 32, added 32. So the recursive formula on this one is to get it in the nth year. I don't know what year, and instead of using x now, we're using just the letter n for a number. So in the nth year, so the amount in the nth year, where I should write, my apologies, nth year, we are going to take the previous year, n minus 1, the total amount in the previous year, and add 32, just like we did each time here. Now, look here, let's see if you are still a little confused on that, that's okay. If I've got 3 here, how many times did I add 32? 3 times. The previous year, 2, how many times did I add 32. Plus 32 plus 32. In the first year, how many times did I add 32? Once. So you can see there's a pattern building. How many times do I multiply by 32? I'm going to, I really wish I had more than one whiteboard right now. But then you would see that I was still wearing my swimming suit from a beach day. So in the third year, I've got 437 plus 32. Could I write times 3 instead? So the number of bottles in year N is 437, what I started with, plus 32 times 3, times 3 in 3 years. So to write a recursive formula, you always have two parts. I just cannot hold on to my caps today. To write a recursive formula, you need two things. You want P of 0. P of 0 at year 0 as your beginning point is equal to, in this case it was 437. So that's the first part of a recursive formula. The second part of a recursive formula is P of n, so in the nth year, that's all we're saying, is in the nth year. To find out how many we have in the nth year, we are going to take the year before, n minus 1. So if this was the 5th year, 5 minus 1 is the 4th year, and add 32 to that. Okay? So that's how we do a recursive formula. Now, where does that explicit formula come from? The explicit formula is a formula that we don't need to know the year before. We don't need to do all those calculations in order to come up with, say, the 10th year. I don't want to have to add 32 10 times. I don't want to take this and add 32 and actually add that together, actually take out the calculator and add that together and then add another 32. I don't want to go 437 plus 32, plus 32, enter, plus 32, enter, plus 32, enter, plus 32. I don't want to do that 10 times. And what if they wanted the 20th year? Oh, that would be horrid. So we come up with a little thing. No, a little formula. It's called the explicit formula so that we can figure it out no matter what. So we know that we start with 432. And if you noticed when I made that table, there was a 432 in every single one, wasn't there? There was a 432. So we always have our beginning number in there, whatever we started with. And then we know that for how many years we're going to take 32. So we could say 32 times how many years we have. 32 times the number of years because we're doing 32. I dropped a cap and now my kitten's got it on the floor. And don't forget we have to add in this first one. Whoops, 437. That is our explicit formula for P of n. Now notice they all have the same numbers. My P of 0 is 432. My P of n says this is what I'm adding each time. But then when we switch it around and switch to our explicit formula, I have P of n, so if I want to find out after so many years, I'm going to multiply the number of years times 32 because that's what I'm adding 32 times. Or not 30, I'm adding 32 that many times, plus 37 in the end. So let's figure out if I do want P of 10, I can do it two different ways. I can take my calculator and add 32 10 times, add 32, add 32. I don't even know what the answer, I don't know how many 32s I've added at this point. Or I can say 32 times n, or 10, plus 437. And I'm going to now do, well, that's 320. So 320 plus 437 is, there would be 757 bottles after 10 years. And I would like you to write that out for a final answer, is after, if we're asking you specifically for how many years, so in a problem, you would write that there are 757, I think that's what I said, bottles after 10 years. Okay? So That's linear with both a recursive and an explicit formula. So we're going to sign off for now, and I want you to remember always, math gives us hope. Every problem has a solution.